AS Level Maths, this is chapter 10 from the Pearson textbook, Trigonometric Identities and Equations. Before I start right at the beginning, there's a few little sort of questions I need to ask. I need to make sure you understand why we're doing the first bit. Most of this chapter is following procedures a little bit, using what you've learned, what you've been taught to answer some of the questions. But this first bit, I need you to wrap your head around what it is that we're doing. So here's a few little questions. The sine of 30, if you wanted to work out the sine of 30, you could either work it out using surd form yourself, using surds rather, in surd form I should say, or use your calculator. Sine 30 is 0.5, and we can use the same process. Cos of 47, these are just random questions I've thrown down. There's 0.682, 0.682, I've done that through three significant figures. Tan of 78 is 4.705. Okay, so the inverse sine of 0.5 should give me 30. And the inverse cos of 0.682 should give me 47. And the inverse tan of 4.705 should give me 78 degrees, and indeed they will. But there are more answers to this. There are more values of theta, if you like, more angles, whereas if I do sine of that angle, I will get 0.5. And you can see this makes sense if you have a quick look at the graphs for sine, cos and tan. Here's sine. So let's look at sine of 30. Sine 30 is around about here, and that will give me 0.5. So far so good, this is 30. But what about this value here? There's another angle here, which will also give you a value of 0.5. Sine of this angle will be 0.5. And we can see from the symmetry of the graph here, the sine curve, this is 30, this has to be 30, that's 180, less 30 is 150. So sine of 150 is also 0.5. In other words, inverse sine of 0.5 is 30 and 150. And I'm sure you can see by the nature of the sine curve, which goes on forever, that actually these values go on forever. There's an infinite number of values. Remember, of course, that sine, as indeed does cos and tan, sine goes in the negative direction as well. So there's an infinite number of negative values. Sine of minus something will give you 0.5. What we're going to learn today is another technique for working out what all these values would be, and they'd go on forever. A different technique, other than sketching the graphs each time and working your way along and trying to imagine where it repeats itself. There's another method, and that's the method we're learning. We're going to start by drawing a grid with all four quadrants, x-axis, y-axis. We're going to consider theta, our angle, as starting on the x-axis and working anti-clockwise. So theta starts here and goes that way. So that's 0 degrees, that's 90. This is 180. This is 270. And this is 360. So that starts here at 0. This is also 360. Now, this next bit, you do not need to understand it in order to be able to follow the process, but I guess it might help. So this point here, this circle has a radius of 1, just to make this explanation easier. So there's some random angle. This point here is the point x, y, x, y. Let's have a look at what this x value is. Well, this x value, the x coordinate of this point, is actually just this distance here. this distance along the x-axis. Now if I consider this right angle triangle with this angle, this is the adjacent, this is the hypotenuse. So I'm going to use cos here for a moment. Cos of theta is adjacent over hypotenuse is x over 1. Now x over 1 is just x. So the x-coordinate of this point is just cos theta. Now that's quite important in this diagram because I'm sure you can see for all these points here, the x-coordinate is going to be positive. So this point here, the x-coordinate is positive. This point here, the x-coordinate is positive. Any angle from here up to here, or indeed down here, so this will be minus 10, minus 20, minus 80. The cos of those angles will always be positive because the cos of the angle is just x. So I know in the first quadrant, cos is positive. I also know cos is positive in this quadrant. Now when I said minus 10 or minus 20 or minus 80, I could also think of this quadrant here as meaning 90, 180, 270, any angle between any angle between 270 and 360. And in fact, the x-coordinate of this point is the same as the x-coordinate of that point, where this angle is the same as this angle. So I can see that actually cos of theta gives me the same x value as cos of minus theta. So I can see from this diagram that cos of theta is the same as cos of minus theta. Now if you look at your graphs, here's cos, we can see it reflects in the y-axis. It's the same this side as this side. So our little diagram here would seem to mirror what we know from our graphs. Over here, the x-coordinate of any point, so therefore the cos of any angle, is going to be negative. If I take this point here, the x-coordinate, this x value, is negative. So cos is negative over here, and it's negative over here. So I'll leave those for now. I'm just going to write in the places where my three trig functions, sine, cos, and tan, where they are positive. So that's my cos diagram. Right, now let's deal with sine. Let's take the same angle here, theta. This length here is the y coordinate, and in terms of our triangle again, this is the opposite. So this is the y coordinate. So I can see that the sine of theta, opposite over hypotenuse, the hypotenuse is just 1 in this case, so it's just y. So sine of the angle is the sine of the sine of theta is determined by the y coordinate. Now anything up here, of course, the y coordinate is positive. Anything down here, the y coordinate is negative. So any angle from 0 up to 180, sine of that angle is going to be positive. And that's reflected in our sine curve. Look at the sine curve between 0 and 180. It's positive. So sine is positive here. Sine's also positive over here and negative down here. But as with cos, if this angle is theta and that's the y coordinate, well, this point here also has the same y coordinate. So the sine of this angle is going to be the same as the sine of this angle, whatever this angle is, up to here. Now, if this is theta, because it's the same as that, then this angle round here is 180 take away theta. So sine theta is the same as sine of 180 take away theta. So if you're dealing with sine, you draw a line like our original black line here and a red line here that reflects around the y-axis. Right, let's deal with tan. Start with the same angle, theta. Tan is opposite over adjacent. So tan theta is opposite over adjacent, y over x. In this quadrant here, both y and x are positive. So tan is positive in this quadrant. As you can see, tan's a little bit more complex than cos and sine. Now, you can see from y over x, if either one of those is negative but not both, then tan will be negative. So if one of them is positive, one of them is negative, tan is negative. In this quadrant here, x is positive but y is negative. So in this quadrant, tan is negative. Similarly, in this quadrant, y is positive but x is negative. And as one of them is negative, then tan theta must be negative. So this quadrant here, tan is negative. What about this quadrant? In this quadrant, both the x coordinate and the y coordinate, let's take a random point here. The x coordinate is negative, the y coordinate is negative, and as they're both negative, then tan will be positive. And in fact, tan of this angle here will be the same as tan of this angle here, because the tan of this angle is y over x, the tan of this angle is minus y over minus x. Now clearly minus y over minus x and y over x are the same thing, give you the same value. So therefore we can see that tan of theta is going to be the same as tan of 180 plus theta. So tan is going to be positive here. So all three trig functions are positive in this area. So instead of writing C, S and T together, let's just put an A for all. In this quadrant here, for angles in this quadrant between 270 and 360, or between 0 and minus 90, depending on how you want to do it, then cosine is positive. In this quadrant, tan is positive, and this quadrant, sine is positive. This is often called a cast diagram or ACTS diagram. It's a diagram that helps you work out alternative values for for inverse sine of various values. So let's see how we'd use this. Let's work out inverse sine of 0.7. Well, we're going to work out our primary value using our calculator first. So shift sine 0.7. That gives me an angle of 44.4 degrees. So what I'm going to do a very quick little sketch of my cast diagram. And examiners like these, just tiny little sketches. C, A, S, T, 44 degrees approximately there. So that's 44.4 degrees. And because it's sine, and sine's positive here, sine's also positive here. So I'm going to draw another line there where that's 44.4. But this angle here, if this is 180 and that's 44.4, this angle here is 180. Take 44.4. 180 take away 44.4 is 135.6. So arcsine of 0.7 is also 135.6 degrees. If you did sine 135.6, you would get 0.7. Now you can carry this on. So we've got 44.4, we've got 180, take away 44.4. We could also then do a complete circle, and then this last angle here, so that should be 360 plus the 44.4 is 404.4. Theoretically, according to our diagram, the sine of 404.4 degrees should be 0.7. Let's try it. Sine of 404.4 is 69.96. Well, allowing for inaccuracies for rounding, that's pretty much our 0.7. So 0.6996, about 0.7. So that's how we do it. For sine, this is the diagram we're going to draw. For cos, let's say I want to do inverse cos of 0.2. Little cast diagram. Work out our primary value. Inverse cos 0.2 gives me an angle of 78.5 degrees. Okay, 78.5 is going to be up here somewhere. And because I'm dealing with cos and it's positive, cos is also positive down here. So I'm going to draw a line here that reflects in the x-axis, where that is 78.5 degrees also. So this angle is actually, you can either say minus 78.5, or you could say 360 take away 78.5. 360 take away our last answer is 281.5. Let's just check that. Cos of 281.5 is 0.2, give or take, 0.2. For tan, the diagram would be like this. Let's do inverse tan of 1.9. C-A-S-T. Let's work out our primary value first. Inverse tan of 1.9 is 62.2 degrees. 62.2. Let's just do a sketch where that is. 62.2. That's positive again. So our other angle is going to be down here where tan is also positive. Let's draw a straight line through the middle now for tan. If that's 62.2, that is also 62.2. In terms of an angle, this is starting here. 180 plus 62.2 is 242.2. 242.2 degrees. So that's a diagram you want for sine, that's for cos, and that's for tan. The same principle applies if you end up with a negative value. So if it was negative sine, then you'd have an angle here, let's say 200 or something, you draw a line here, and then the other one here, because you know the answer is negative. That's an introduction to cast diagrams and how you can use this diagram to help you work out several values for your angle that meet a certain criteria here. Now just watch out in the question what the range of values for theta or x that it gives you. I've assumed that the angle can be between 0 and 360. It could be between minus 180 and 180. It could be between 0 and 720. Just keep an eye out for the range of values. If it goes up to 720, then you just keep going with this idea and you just write down the remainder of the values.